Alright, so we are doing points and their equations, so we're going to be doing some stuff with graphs. And this is 5B day 1. So learning goals for this particular lesson: I can determine if a coordinate pair is a solution to an equation, I can match a table to a function, and I can use information given in a graph to solve a real-world problem. So first, let's make sure that you understand you know what a solution is. So a solution is a coordinate pair that will make the equation true. So it's said to satisfy the equation. So example, if we have points that are on a line, so any point that's on the line is going to be a solution. And remember, the line is a representation of the function. Any point not on the line, not a solution. Alright, so for example, we're being asked, is the ordered pair a solution to the linear function? And we have the points 2, 2. And we have the linear function 4x plus 3y equals 14. So all you have to do here is take your x value and your y value and plug them into the function and see if the right side and the left side match up. So important thing to note here, we are not doing anything going back and forth across the equal sign. We are only plugging in our x value for our x value and our y value for our y value. That's it. Alright, oops, did not mean to go ahead. Or back, I should say. So we plug in 2 for x and 2 for y, set it equal to 14. Do the equation there. So 4 times 2 is 8, 3 times 2 is 6, so we have basically 8 plus 6, which does equal 14, which matches what's on our right side. So yes, it is a solution. Obviously, if this was something else, let's say this was the point 2, 3. If this was 2, 3 instead, we would have 4 times 2 plus 3 times 3 equals 14, which would give us 8 plus 9 equals 14, which is 17, which does not equal 14, and in that case, that would be no. So just keep that in mind. It's not always going to be yes. Alright, now we need to find which table values can be used to graph the function y equals negative 2x plus 5. So keep in mind, our y, we need to figure out what our b and our m is. So in other words, our slope and our y-intercept. So our slope is negative 2. Because remember, that's always in front of the variable x. And then 5, because we have a positive 5, so that's our b. So go through, and you can, some of these you can tell really easily what the b is. Like if we look at this first one, we've got where x is 0, y is 5, so that's our y-intercept. And then to find our here, it's not as apparent, so that we don't know. I'm not saying you have to go through right away and find out. We did go, cover that in a previous lesson, so you can do that if you like. But then you can look at your other one and say, okay, well, I've got a 0, 5 here as well. So that has y-intercept of 5. So we have two that have y-intercepts of 5. So it's more than likely either A or C, but we can't rule B out yet. First, we want to find out if the slope is the same. Because if it's not the same, we don't need to bother and figure out what the y-intercept is, because we know that this table couldn't be used to graph that function. So next thing, we need to find the slope. And remember, that's y1 or y2 minus y1 over x2 minus x1. So I'm going to take my y values of 3 and 5. So I'll do 3 minus 5. Since I started with 3, I have to start with negative 1 and then also 0. And that gives me a slope of positive 2, which does not match with this. So we know it can't be this one here. So that's no good. Let's go ahead and find our slope over here. We've got 14 and 8, so I'll do 14 minus 8 over negative 3 minus negative 1. Be careful with these, because that should read like that. You can put parentheses around that if it'll be helpful for you, because then that's actually negative 3 plus 1, don't forget, which will give you a slope of negative 3, because 14 minus 8 is 6. Negative 3 plus 1 is negative 2, which would give you negative 3. So that's how we got that. So that slope doesn't match up, so we don't need to find that. So that doesn't work either. Let's make sure that C works. So we know that the y-intercept is the same. I'm going to go ahead and pick my y and my x values. 5 minus 3 over 0 minus 1, which does give me negative 2. So C is correct because this matches with this and our 5 matches up here. So a little bit of work to do on this one, but you want to make sure that you are doing everything. So even though we know that we don't know what the y-intercept is, we don't want to just give up on that problem yet either. Alright, last example. Ron owns a fish store that sells fish by the pound. The graph shows how the number of pounds in the store changes with the number of customers. So if there were 10 customers, how many pounds are left? So this is as easy as we have our graph, number of pounds in the store, and then we have number of customers. It's asking if there were 10 customers, so I find 10 on the axis that's labeled number of customers. And all I have to do is go up and find out where my graph crosses that part on the that value of x. And then I just go over to y, and this is directly in between 100 and 800, which is of course 900. So the answer is 900 pounds. Simple stuff. So the previous example had a little bit more work to do, but for the most part these are fairly easy. Make sure that you understand them. If not, go ahead and send me a question or ask people in your group, whatever it is you need to do. All right.